this is another series or sequence or number pattern question. It is given that the general term of a quadratic number pattern is Tn. So we have Tn is equal to n squared plus bn plus 9. So and then they also gave us that the first term of the first difference is 7. First difference is. So we want to show that b is equal to 4. So we have the general term of our quadratic number pattern. It's represented by this little equation right here, or formula. So we could lay out a few terms of our quadratic number pattern. So like we could lay out T1, which is the first term, and we could lay out T2. We could also lay out perhaps up to T3. So T1, that means n is 1. So I could substitute here 1 where there is n. So to get T1, let's see, T1, I would have 1 squared plus b times 1 plus 9. And then to get T2, I would substitute 2 there. So then I would have 2 squared plus b by 2 plus 9. And again, to have T3, I would substitute 3. So I would have 3 squared plus b by 3 plus 9. So each one, this one should give me, if I work it out, 1 squared is 1, and then b times 1 is b, so it's 1 plus b plus 9, and this one here would give me 2 squared, that's 4, plus b times 2, that's 2b, plus 9 there. And then the third one would be 3 squared, that's 9, plus b times 3, that's 3b plus 9. So if I add 1 and 9 here, I would have b plus 10. That's the first term. And then if I add 9 and 4 and 9 here, I would have 13. So it would be 2b plus 13. And then here it will be 3b plus 18. So these are the first 3 terms of my quadratic number pattern. So I know that for quadratic, I would have the first differences. So the first difference is, I would say this minus this, right? So I just want to work it out on the side so that we can understand what's going on there. So I would have 2b plus 13, right, minus, so it's 2b plus 13 minus b plus 10. So I have to put that in brackets, b plus 10. If I don't put brackets, then my negative here, my minus, would not affect everything. Then I would get wrong things. So then it becomes 2b plus 13, then negative affects everything in the brackets, so it will be minus b minus 10. And then 2b minus b, that's b. And then 13 minus 10, that's 3. So that is essentially my first term in my first differences. So b plus 3. And they already told me something about the first term in the first differences. So for now, I'm just gonna put, I'm just gonna write here b plus 3. If I say 2b plus 13 minus b plus 10, it gives me b plus 3. Let's remove this for now. And again, if I do the first difference for these two, so if I say 3b plus 18 minus 2b plus 13 in the same manner, let's just quickly do it. So it's 3b plus 18 minus, again I have to use brackets so that everything is affected by the minus, 2b plus 13. Then I'm gonna have 3b plus 18 minus 2b minus 13. Then 3b minus 2b, that's b. And then 18 minus 13, that is 5. Okay, so that gives me the next thing, which is b plus 5. That's the next first difference between term 1 and term 3 and term 2 of my quadratic. So let's just remove this. And we know also that for quadratic, we also normally find second differences, right? So I can do second difference between this one and this one. So I'll say b plus 5 minus b plus 3. So let's again quickly do it on the side. It will give us b plus 5 minus, again I have to put it in brackets because there is more than one term here, so the negative has to affect both. So b plus 3. So it's b plus 5 minus b plus 3. So b plus 5 minus b minus 3. B minus b, that's 0. B minus b, that's 0. 5 minus 3, that is 2. So our second differences will be 2, 2, 2, 2. Let's remove this here. Right. Now, let's remember what the question is talking about. So the question wants us to show that b is equal to 4. Right? That's what the question wants us to show. So how do we show that? We have already been told that here, there is this point here, that the first term of the first differences is 7. The first term of the first differences is this one here. That's the first term of the first differences, because these are first differences. So if we have been told that it's 7, so we can take b plus 3 and we equate it to 7. So we can say b plus 3 is equal to 7 because we have been told that it's 7. Then here we solve for b. I would transpose 3 to the other side, or take it to the other side. So that is b is equal to 7 minus 3. So b is equal to 4, which is what they want us to show on this question here. So that's how we solve the first question. Now that we know that b is equal to 4, we just want to do a few things to clean up this, because we know that our quadratic sequence or quadratic number pattern is this. The first 3 terms is this, right? Now that we know that b is 4, we could substitute b4 here, 4 here, 4 here to find the actual numbers, and also even here. So So if I were to substitute, I can see that maybe let me remove a few things here. So if I come back, I would see that if b is 4 plus 10, so the first term is 14, then the second term is 2 times 4, that's 8, plus 13, that is 21. And then here, 3 times 4, that's 12, plus 18, that is 30. So this is my quadratic number pattern. And then 21 minus 14, that's 7. And then 30 minus 21, that's 9. And the second difference is that's 2. So, okay, now let's just park that there for now. Let's look at the next question. The next question says, it says, determine the value of the 60th term of this number pattern. 60th term, that means T60, right? We have Tn here. So for 3.2, we want T60. So T60, you'd substitute 60 where there is n. So it's 60 squared plus b by 60 plus 9. But we know what b is. So 60 squared, that's 3,600 plus 4 by, because we know that b is 4 from this question. 60 plus 9, so that is 3,600 plus 240 plus 9. So that should give us 3,849. That is T60 for 3.2. So then 3.3 says determine the general term of the sequence of first differences of the quadratic number pattern. Write your answer in the form TP equal to MP plus Q. So what they want, this is 3.3. They want us to determine the general term of the sequence of first differences. In many cases, like always, in all cases, the first differences of a quadratic number pattern, these ones here, like 799 here, they always make an arithmetic sequence or pattern because they have a constant common difference in the second differences here. So all their all their differences will be 2, 2, 2, 2, 2 if we were to continue this this sequence. So we know that it's arithmetic, and let's remember the general term of an arithmetic sequence is Tn equal to a plus n minus 1 by d, where n is the position of the term and d is the common difference. Now we already know what d is in this case. We know that this 2 is the d. That's the common difference between the terms of our arithmetic, which is the arithmetic sequence is the sequence of the first differences. So we know that d is equal to 2. What about a? We know that a is the first term of our arithmetic sequence. Let's never forget that for this question, 3.3, we are focusing on the first differences. We are focusing on the sequence of the first differences, which is an arithmetic, and this is the general term of an arithmetic, the formula. The common difference is 2 because that's the difference between T2 and T1 of our arithmetic. What about a? We know that a is the first term, that is 7 there. Okay. So I'm just going to write Tn for now. I know they said Tp, but we'll get to that at the end. So we are used to Tn, so let's use Tn for now, then we'll change. So Tn is equal to A, that's 7, plus n minus 1. We don't know what n is, so it's fine. By d is 2. So I'm going to simplify here. So Tn is equal to 7 plus 2n minus 2. So I multiplied 2 times n, that's 2n. 2 times negative 1, that's negative 2. And then 7 minus 2 should give me 5. So Tn is equal to 2n plus 5, because 7 minus 2 is 5. So they want Tp, so let me change n to p. Nothing else changes there. So Tp is equal to 2p, because each n is becoming p, so Tn becomes Tp. 2n becomes 2p plus 5. That is the solution for 3.3. Okay, now let's remove this and make space for the next question. So the next question, that's 3.4. 3.4. Okay, so for 3.4, it says here, which two consecutive terms in the quadratic number pattern have a first difference of 157? Now, we are still talking about this pattern of first differences, which starts with 7 and goes to 9 and keeps going. We don't know the other terms, but it keeps going. Now, we are the question is, in the quadratic number pattern, which two consecutive terms, like terms that come one after the other, in the quadratic number pattern have a first difference of 157? So a first difference of 157 will be between which terms? Like, for example, the first difference 7 is between term 1 and term 2. The first difference 9 is between term 2 and term 3. So we want to find 157 if I were to continue. In other words, if I were to continue this sequence of first differences until I get to 157, that 157 will be between which terms of the quadratic number pattern? So in other words, I have to find, in the arithmetic sequence of first differences, 157 is term number what? That's essentially the question I'm trying to find here. So I want to know Tn is equal to, I know that Tn is equal to 157. I just want to find what n is. But I don't need to use n, it's just that I'm used to n. But here we found Tp, right? Tp is equal to, we found it to be 2p plus 5. 2p plus 5. So we know that this Tp is 157. So we want to know, if Tp is 157, what is p, which is the position of the term 157. I mean 157, not term 157. So I have to solve this equation to find p. So to solve that equation, then I have to take 5 to the other side. I take 5 to this side, and I will remain with 2p on this side. 2p is equal to 157 minus 5. And that's 2p is equal to 157 minus 5. That's 152. Right? Then I have to divide both sides by 2. 2 and 2 cancel out. 2 into 157, that's 70. 76. Okay, so P is equal to 76. So in other words, if I were to continue the sequence of first differences until I get to 157, 157 would be the 76th term. It would be the 76th term of the sequence of first differences. So this would be the 76th term, right? Now we want to know, like, what about this term and this term, between which we find 157? What would be their term numbers? So I know that this is T1, or the first term, right? You find it between T1 and T2 of the quadratic. This 9 is T2. You find it between T2 and T3 of the quadratic. So T76 would be found between T76 and T77. If you just notice the pattern, T1 and T2 give you T1, T2 and T3 give you T3. So then T76 would, you get it from T76 and T77 from the quadratic. So so it would be the 76th and 77th terms of the quadratic number pattern. So that's how we solve this one.